Hello everyone, welcome back. In this lecture, we will learn how to visualize data as scatter plot, line plot or bar plot, and while doing so, I will use R to make those plots. So, in a way, in this lecture, we will learn how to create, when to create scatter plot and bar plot and how to create them using R. Now, you must be knowing that the scatter plot, line plots and bar plots, these are the most common method of visualizing data and the oldest one also. So, already you must be creating those using some other software like Excel or something like that. What you will learn here, you will learn how to make those using R, and I will also discuss certain important issues that you have to keep in mind when visualizing data as scatter plot or a bar plot. So, we will start with scatter plot. To create a scatter plot, I will be using a inbuilt data set called the DNS data set in R. In this data set, what you have a ELISA assay results, right. So, in this what they are doing, they are assaying the enzymatic activity of an enzyme called DNase, and they are measuring that activity in through a method called ELISA. So, what you have the data for different concentrations of the enzyme versus the absorbance they measure at the end of the ELISA. And not just that, they have performed the experiment or repeated the experiment many times. So, all those repeat data are there. Let me first read that data and then I will explain how the data has been arranged by them. So, I will read it. This is a default data set. So, I will store that in D. So, let us open the D. Let us see what we have. It has 176 observation. The first column is for run. Second column is for concentration and the third one is density, that is the absorbance or optical density actually. If you look into the first two reading, right, the run one, the concentration of these two rows are same. So, that means this is run 1, the first experiment, they have multiple repeat, those repeats are called run, and for each repeat there are around 8 concentration of the enzyme used for the assay, and for each concentration they have measured the taken the reading twice, right. So, that is why you have 2 reading for concentration 0.048, 2 reading for concentration 0.195, something like that. And then if you go down, you can see there are 8, 9 and 10 up to 11 different repeats, right. So, they are independent runs, independent repeats. To increase the reproducibility of the result, they have repeated it so many times. So, what I want to plot this concentration versus density plot. Concentration should be in horizontal line, density should be on the, or absorbance should be in the vertical line, and as you can see, this is a pairwise data. For each value of concentration, I have a reading for absorbance or optical density. So, if you remember, scatter plot is usually used for visualizing this type of pairwise data, where I have 2 variables and their values are smoothly changing, right. So, here concentration values are smoothly changing, along with that the optical density of absorbance is also smoothly changing, and I have a pairwise data set for that. Let me go back to the script. Let us first make a scratch scatter plot. So, what I will use the plot function. Plot function is a very powerful function in R. It can do lots of things. It can generate lots of type of plot in different fashion. So, what it will do here, by default I have given the concentration and density as x and y, the horizontal axis variable and the vertical axis variable here, by putting $con, that is the concentration, that is in the second column, as the x, and density as the second one. So, what it will do, by default it will create a scatter plot. Let me zoom the figure. So, you can see all the data points has been plotted. Okay, you may not be expecting this type of plot, I can understand. Maybe you want to plot the mean of each repeated measurements or something like that, but we will go to that in a moment. So, this is the basic plot I have got. What I will do now, I will do some amount of formatting, and I will explain what type of formatting you should do while creating a plot and what issues you should always pay attention to. So, to do formatting, I have to use certain arguments, right. So, plot has lots of arguments that we can use. I am just using few of them. If you want to know all of them, please look into the help file or the documentation of R for all the arguments that you can use to format the graph. So, obviously, x and y is defined at the very beginning. Then the second argument that I use that label the x axis. So, x lab is equal to concentration in nanogram per ml. Y label, the vertical axis label is Y lab and it is absorbance. PCH is the name of the symbol. R has some inbuilt symbol. If you go to the documentation, you can get a list for that. I am using 3, so it will be a cross or a plus sign in a way you can say. Color of that symbol I want blue. The size of the symbol I have written CEX equal to 2. By default, R will consider a size of the symbol. I want to increase it 2 times. So, I have written CEX equal to 2. Then I have said CEX dot axis equal to 1.5. That means, see in the axis I have the labels, right, 1, 2, 3, 4 something like that for the concentrations and also the absorbance. So, those are fonts and R use a default font size for that. I want to change that font size by increasing it to 1.5 times. Similarly, the labels, the x label, y label that we are defining here, I want that the size should be 1.5 times of the default one. Here I plot it and then I will explain these things again. So, let me zoom out. So, if you can see now, the labels and as well as the tick labels are very legible. This is one point we have to keep in mind while we are creating a plot, that all the text and numbers should be legible to the person who is reading or seeing that, right. I should not use very small font that somebody cannot understand what is written there, or I should not use a huge font that the font become predominant rather than the symbols and the other aspect of the data. So, judiciously I have to always choose the font size. Second important thing, or rather I will say the most important thing while you are creating a plot is that please always label your axis. A graph without axis is not labeled is meaningless. For example, here the horizontal axis must be labeled as concentration and I will insist always put the unit of that concentration used. For example, here it is nanogram per ml. Whereas, the vertical axis we have written absorbance, I could have written it as an arbitrary unit in the bracket. Usually people know that absorbance is not an absolute reading. So, they know there will be an arbitrary unit of that. I could have added here the wavelength at which the absorbance has been taken. The next thing is that symbols and color should be chosen in such a way so that I can easily understand the pattern in the data. I should not choose a color or a symbol that obscure the pattern of the data as well as the aesthetic of the visualization. So, I have plotted it. Now, once you have seen this plot, you must be thinking that usually you do not do it this way, right. You do not plot all the data point at scatter point and visualize for this type of experimental data. What you prefer is that you want the mean of each repeated runs, right, each repeated measurement. So, for each concentration you have 11 runs and for each run there are 2 repeats. So, you have so many reading for each of the concentration. So, you want to take a mean of that and plot that. So, to do that I have to calculate the mean of it, right. So, how I will do? Now, if I go back into the data D, I can see that in this case the data is stacked based on the run, right. The first run data is there, then it is you have the second run data and this goes on. And also in each run you have for each concentration you have 2 readings. So, I have to somehow sort out this and calculate the mean. So, do that what I am using here the function called aggregate. I want R to aggregate the data based on what? I want to aggregate the density data, that second column density data based on the value of the concentration CONC, which is that the second column, name of the second column is second variable is CONC concentration. So, I want to aggregate the density data with respect to or based on the concentration data from where? From the D variable which has all the data, and while aggregating it will you calculate the mean. That is why the mean is written as the last argument. So, if I execute this and then let me see the I have created D average variable where this aggregated data is stored. Let me open that. You can now see you have 8 data points, right, because I have 8 concentration in this experiment, right. So, 0.0488 up to 12.5, and the second column is actually now the mean density that we have got through the repeated measurement. The mean of those repeated measurement for that particular concentration in that column. So, now I want to plot this concentration versus density plot or concentration versus mean absorbance plot. So, to do that, what I will do? I will again use the plot option. It will be a scatter plot. Everything remains same. Only thing I have done here, now I have changed the symbol. I am using 19, PCH equal to 19, so that it will be a filled circle and the color will be blue. So, here is the plot. Now, you can see it looks neat and you must be recognizing it because you may have created this type of plot earlier for your lab work. So, these are showing me the mean absorbance for each of the concentration. Now, if you carefully notice what has happened here, I have some issue with respect to the scale of the axis. We start for the vertical axis, we are starting from 0, 0, we have the tick mark up to 1.5, but you have a data which is bigger than 1.5, but I do not have any tick mark for that or above that. Similarly, my reading is slightly more than 12, but I do not have any tick on the right hand side in the horizontal axis. So, I want to correct them. To do that, what I will do? I will use two argument x lim, y lim, right. So, this will limit the scale. So, I am putting x lim equal to C 0, 14. That means, I want the ticks to start from 0 up to 14 for the horizontal axis, the concentration axis, whereas y lim is equal to C 0, 2. So, I want it up to 0 to 2. So, if I now plot this one is much better. Now, I have all the tick level and all my data are within this scale for both vertical and horizontal axis. So, what I have shown here is the mean data, and you must be wondering that where is the error bar, because every time you plot this type of average data, mean data, we are supposed to put the error bar, which in this case can be standard deviation. Now, by default R does not have this plot of function does not have any way to create the error bar. That is quite unfortunate. There is a roundabout for to do that. That is a bit complicated. I will not go into it. In future lectures, we will learn about some advanced packages for visualization of data and for creating graphics which will be publication quality. So, in that case, we will be able to easily put the error bar, and we will discuss that at that time. Now, I will move into another type of data set. What we have here, I have rearranged the same data in a different way, because in some of your experiments your data may not be arranged the way we have in this particular data file. So, I have created data file using the DNS data, a part of it, to show that maybe your own data may be arranged in this particular fashion. So, that is in a ELISA.csv file. I will read it and then explain what is the data pattern format. So, this may be usually the way you may store data in your Excel sheet when you are doing this type of experiments, right. So, you have the first column is the concentration. So, you have 8 concentration and you have taken multiple reading for the same sample, or you may have repeated the experiment with the same concentration. So, all those repeats are now stacked in columns. So, the first observation is the second column, second observations are in the second column, and so on. So, for each of these concentration I have 4 readings, right. This may be the way you have your data, and you want to create the scatter plot. So, again this is pairwise data. Again, rather than plotting all the data points, what you will prefer to get the average of that all these observation, 4 observation, and then plot them as a scatter plot. So, I have to get the mean of these 4 observations, right. I have 4 repeats, absorbance 1 up to absorbance 3. For each concentration, I have to take these values and calculate the mean of that. To get the mean, what I will do in this case, I will use the row means functions. Row means function will take one row at a time and calculate the mean of the data in that row. So, what is the argument for that? Okay. I want only the second column up to 5th column data, right, because the first column is for concentration. I do not want to use that while calculating the mean. So, I will take this second column to 5th column and all rows from this E and calculate the mean for each of them, each of the rows. So, to do that, what I have done as a argument, I am writing E in the square bracket. The index of row I have left empty, that means I want all in rows, and then in the column index I am writing 2:5, that means take from column 2 up to column 5, and if I execute this, I will get the row means data, and I am storing that in abs.mean variable. So, I can print that data here, the mean values you can see. Okay, I have 8 values here because I have 8 concentration. For each concentration, I have now got the mean values. So, now what I will do, I will plot these concentration versus mean absorbance. Again, I am using the same plot for scatter plot. I will not go in detail of that because we have already discussed how to use that and the arguments. Only one important thing here I have to remember, the x axis will be $conc because that is the concentration, the first column, and the y argument for y is abs.mean because I have the mean data there. So, if I run it, here is my plot. This is the plot, similar plot I have got earlier also. So, now what I have done, we have discussed till now about scatter plot. I have plotted the scatter plot for the same data, but arranged in a different format, and I have initially plotted all the data point at scatter points, and then I have plotted the mean. Now, you may be wondering that many a time we prefer to join these points with lines, right, or sometimes we simply do not put these points as a symbol, rather we join them as simple lines and we only do the line plot. So, I can have 2 types of line plot where we do not have any symbol for data point, only the line, and other can be the scatter plot combined with line. So, what I will do now, I will create a line plot for this same data where there will be scattered points also, the points will be there, this symbol circle, field circle will be there for each data point, as well as these data points will get connected by lines. Now, to do that, what I will do, I will use the same plot function, but as I said, plot function is very powerful. So, what I will do, I will add few extra arguments. What the argument I have to add? In the plot function, I will say, okay, type is equal to B. B means both. By that, plot function will understand I want both the symbols for each data point as well as I want to join them by a line. If you do not want those symbols, do not want the scatter points, then you put type equal to L, lowercase l, that means you want only the line. So, in this case, I want both of them, and in a second you will see how it looks, and I want the width of the line LWD is equal to 2. Here is the plot. So, you can see here now I have the scatter point and I have joined them by line segments. So, it has both the scattered data points as well as the line. Now, this one we should not confuse with data fitting. Many a time you may initially plot this scattered plot and then you may fit this data by a smooth line, which is a particular function. Now, that is usually done when you are doing regression model, right. We will discuss those separately. Here what we are doing, we are not adding any smooth line, we are just joining these data points by line segments. So, that is all for the scatter plot. Now, I will move to bar plot. Bar plots are usually used when you have category based data, and I will explain that with a particular example. To understand what is bar plot, when to use a bar plot, and how to create a bar plot in R, I have a flow cytometry experiment data. Before I move into it, I want to highlight that for the scatter plot that I have shown earlier for my enzyme assay experiment, I can also use a bar plot for that. But in that case, it does not add any extra value and it does not look aesthetically good also. That is why it is preferred that I will go for scatter plot. There are certain particular cases where scatter plot cannot do justice to my data, and in that case bar plot should be your first choice. So, for example, the flow cytometry data that I will discuss here is one such example where bar plot is a must, you cannot use a scatter plot. So, before I move into that data, let me load the data and explain what we have. It is in this fax2.csv file. So, let me read that first. Let us check the data. So, what I have in this experiment? What I am doing? I am checking whether a particular drug treatment can cause cell cycle arrest of some cells or not. I have two drugs, or you can imagine two doses of the drug. Here I am labeling them as drug A and drug B, and I have untreated cells. So, I have three samples: untreated cell, cell treated with drug A and cell treated with drug B. And using flow cytometry, what I am doing? I am measuring percentage of cells in different phases of cell cycle. I hope you remember cell cycle. So, here different phases are sub G0, G1, S and G2M. So, I have 4 cell cycle phases and I have repeated this experiment, perform the flow cytometry, and the mean observation is shown here in this file. So, now I want to use a bar plot to represent the data. So, first what I will do, I will simply make a bar plot for these untreated cells, and each of the bar will correspond to each of these cell cycle phases. To achieve that, what I will do, I will use the inbuilt bar plot function, but before I go into it, I have to do some transformation and processing of my data. So, what I want? I want the untreated samples. So, let me extract that. So, d dot un is equal to d first row 2 to 5 column, right. So, 2 column 5. So, I am taking the first row of the data and I am taking it for 2 to 5 because the first column has the label of the sample, I do not need that. And now to use bar plot, I have to convert this data frame into a matrix. To do that, I am using data.matrix function and using d.un as a argument, and I am saving that matrix again in d.un. So, now I will use the d.un as an argument for bar plot function to create bar plot. So, in bar plot function, the first argument is now d.un. I am setting x y limit, y will be the vertical axis, this limit, it is a percentage of cells. So, it can minimum value will be 0, maximum will be 100. So, I am setting y limit equal to c 0 comma 100, and the label of the vertical axis is percentage of cell. So, if I execute this script, first I am creating the data set and then I am plotting the bar plot. So, let me zoom in. So, this is a standard bar plot you expect. So, I have in the horizontal axis 4 categories. Remember here this is category data, right. So, I have 4 categories sub G0, G1, S, G2M, and for each category these are untreated cells. So, there are percentages of cell data. So, for example, almost 80% of the cells in this untreated population are in G1 phase, whereas very little, maybe 2%, 3% are in sub G0 cell, which is expected for an untreated sample. Now, in this case also you may be expecting that I should have error bar. Yes, actually in bar plot if you have multiple measurement, I should have the error bar because I am plotting the mean. Again, bar plot does not have the option to draw error bar here by default. There are advanced packages which we will learn later on, where I have the option to put the error bar, and we will put the error bar then. Now, usually when you do multiple sample experiment, for example, I have 3 samples, right? You do not want 3 separate bar plot for them. You want the data for untreated, treated samples together in one single bar plot, so that you can make a comparison between them, right? And that is what I will do. How I will do that? Again I will use the bar plot function, but I have to rearrange the data and I have to add some arguments to that. So, to do that, first what I will have to do is that I have to get the data and convert that into matrix format. So, now in this case I want all the rows for column 2 to column 5. So, what I am doing? I am saying D, the row index I am leaving empty, and then 2 colon 5, that means from column 2 to column 5 for all rows you take it from D and then convert that into matrix using this data dot matrix function. So, I have D dot val which will store these values. I can look into that. Now, I have a matrix with the values for each of these cell cycle phases for each of these 3 samples. Now, I will plot this data as bar plot. So, before I explain what type of argument I will put here, let me first plot it, so that it will be much easier to explain the argument. So, I have plotted the plot and bar plot with all these 3 data set. Let me zoom into, so that you can easily see it clearly. So, what I have here? I have data for all these 3 samples, treated, untreated, right. There are 2 treatment group, drug A and drug B, and the data are got stacked side by side. So, how we have stacked? So, look into the G1. The first one, as per the legend drawn here, is for untreated sample. The second bar is again G1 for drug A treated sample. The third one is for drug B treated samples, right. So, all the 3 samples data for G1 phase are stacked side by side. Similarly, for other phases As, G2M and sub G0, you have this data got stacked. And in this you can easily understand that for drug B treated, a large proportion of cells are now in sub G01, and that has caused in decrease in G1 phase cells, whereas some G2M and S phase cells has also increased for drug B treated, whereas drug A treated samples are almost similar to untreated one. So, how I have achieved this using the bar plot function? Let me explain that now. So, the first thing is that obviously the D dot val is the argument. So, that data matrix with all these 3 sample having 4 phases of cell cycle is my input argument, first input argument for bar plot. Then I have written beside equal to true, that means this bar will be plotted side by side. If I have not used that beside equal to true, then data would have got stacked. And then I have set the limit of vertical axis to 0 to 100. I have labeled percentage of cell as the vertical axis label, and by default bar plot is plotting legends, right. So, do that I have mentioned what should be the legend text. So, I have said untreated, drug A and drug B should be my legend text, and I have some added argument for legends. So, that is args.legend, and that those are to set the position, whether I want a box around the legend or not. So, I have said x equal to top right, that means the legend should be arranged on the top right position, and I do not want any box. So, I have written bty equal to n. Now, what I will do? I will add few more formats here, formatting things here, right. So, first thing what I will do? I will change the color of this bar. So, by default R is using its default color scheme, which looks good, but and is good for black and white printing and black and white representation of data. But if you want to add some color, how can you do that, right? So, to do that, what I am doing, I will be using 3 color, because I have 3 sample. One will be light pink, another will be turquoise, and it will be pale turquoise actually, and another will be misty rose. R has inbuilt lots of colors, hundreds of them. you have to go to the R documentation to find them. You can specify them by name, you can specify them by numbers also. I am specifying them here by name. So, I am creating a list of these 3 color and assigning that to my call, so that I can you call it later on. So, now I will plot the bar plot, right. What I am doing again side by side. So, beside is true, the same data set. The only thing I am changing here is color equal to call equal to my call. So, the default color will not be used anymore, and also what I am doing, I am changing the font sizes. So, I am saying okay, the access labels should be 1.5 times of the default one. So, CEX dot access is 1.25. So, the numbers will increase their font size, right. The CEX name 1.25, the names will be font size of the names will be 1.25 of the default one, and the label font will be also 1.25, right. So, the label is the percentage of cell in the vertical axis that I have written, and the names are the names of these groups, that is cells, different cell cycle phases, right. So, if I execute it, I get this type of diagram. If I zoom in, you can see I have 3 different color. So, if you want a color bar plot, this may be the better way to do it. You can change the color as per your requirement. So, this brings us to the end of this lecture. What we have learned in this lecture? We have learned that when I have to go for scatter plot and when I have to go for a bar plot, and we have learned how to perform create scatter plot with lines and bar plot using R. As I said, we are using the default functions for R for plotting. Those default function has lots of limitation. At the same time, they have lots of options also. R itself is very flexible. I have only scratched on the surface of these default functions for bar plot and scatter plot. If you practice them, use them and play with the arguments, you may actually create very good quality plots. But there are packages in R dedicated to create high quality publication grade graphs, and we will discuss them separately in separate lectures. So, thank you for learning with me in this lecture. See you in those lectures too.